Hope audio video is okay. Let's check one time. One time verify is audio video okay or not. This is the place where we stopped yesterday. Yesterday we stopped here. So 15 problems we done. Right? DFA, NFA construction, approximately we done the 15 problems. Okay, let me delete if anything. Just wait. I think fine. Audio video is okay. Verify. Can we move to next? Right. Let's go to problem number 16. Today I think date is 27. I think so. Today is the 27. Yeah, I'm going there. 27. Problem number 16. See the problem number 16. Right. Let me write. Construct minimal DFA for the language L is equal to, careful, this is the very interesting story, right? Very interesting story, please be careful. Construct minimal DFA for the language L is equal to number of, right, language L is equal to all strings of A's and B's where number of A's divisible by 2 and number of B's divisible by 3. Right? This is the problem. So only A is divisible by 2, you know very well, like above problem, 2 states. Number of B is divisible by 3, I think like above problem, 3 states. So individually, you know, sometimes they will ask you combinedly. Right? What will be the answer? We'll see now. Combinedly, they will ask. Can you see the yesterday's problem? See this one. Where each string contains number of A's divisible by 7. Number of A's divisible by 7 contains 7 states. Minimal DFA also, minimal NFA also. NFA also 7. Because no dead state. Right? Because every DFA is NFA. Every NFA is not DFA, but every DFA is NFA. Right? Minimal DFA for this problem, minimal NFA, same number of states. Because no dead state is there. Right? Fine. I think people got it. Only A is divisible by 7, you know. Only B is divisible by 5, you also know. Right? But whenever combined ask, how you are going to solve? Construct minimal DFA for the language L is equal to all strings of A's and B's where number of A is divisible by 2, number of B is divisible by 3. How you are? Very simple. See this one. Number of A is divisible by 2. I think you know 2 states. Number of B is divisible by 3. So 3 states. You know this very well. And if you multiply 6 states, remember everyone, 6 states. DFA possible. I cannot say it is a minimal or not, but it is a DFA. Right? Simply multiply. I cannot say it is a minimal DFA or not, but for this problem, it is a minimal DFA. For this problem, it is a minimal DFA, but I cannot give guarantee for every problem minimal will come or not. Why? What is the reason? I will say. See this one. If different symbol, number of A is divisible by 2 states. Number of B is divisible by 3. So here A symbol, here B symbol. One problem only, one condition on A symbols, one condition on B symbols. Then you can multiply happily. Right? Minimal DFA also contain 6 states. But some conditions are there. I will explain those also. Some people are asking, sir, how 6 states are? Very simple. So just covering every possibility. Right? One A covering all B possibilities. One more A covering all B possibilities. One more A covering all B possibilities. Something like that. So I will try all the possibilities out. So some people are asking, sir, how can you give one example? I will try one example. This is called product machine. This is called as a product machine. Sir, divisible, number of is divisible by two states. How, sir? You know very well. S1, S2. Number of is divisible by 2. Means I think 0 is also divisible by 2. 1A, no. 2A is yes. B's may come, may not come. In the first part, A is only our concentration. Assume that it is the P1. Assume this is the first problem, P1. In the P1, our concentration is A is divisible by 2. Okay. Let's go to P2. In the P2, if you see, right, number of B's divisible by 3. Right, 3 states. So let's do the P2 one time. S3, S4, S5. Number of B's divisible by 3. So 1B no, 2B no, third B yes. A's may come, may not come. In the P2, our concentration is only B's. Right? How the product machine? Individual machines, if you know, product machine also you know. Sir, how, sir? Just very simple. Just to do Cartesian product, S1 will multiply with all of P2. S2 also multiply with all of P2. Sir, how, sir? S1, S3. S1 will be multiplied with P2, all the people. So S1, S3. So S1, 3. S1, S4. S1, 4. S1, S5. S1, 5. Means first state of first machine will be multiplied with all the states of second machine. Similar way. Right? Second state of first machine S2 will be multiplied with, right, second problem, all the states S2, S3, S2, 3, S2, S4, S2, 4, S2, S5, S2, 5. Okay, this is called product machine. How the states are? So number of states, how many are? Simply multiply 2 into 3, 6 states. Now next one, further house are whichever is the common initial state. I think here S1 is initial, here S3 is initial. Right? Where S1, S3 both are there, that is the common initial. Right? Wherever common initials are there, that is the final initial. Okay, fine. Now one more thing, end operation. Remember, it is the end operation. End operation. What I mean? Both the things should be satisfied. Satisfying first one means S1 final. Satisfying second one means I think S3 final. Satisfying both end operation means both should satisfy. Wherever both finals are there, that is the final. I think both the finals are here. S1, S3. See, here final S1, here final S3, where both the finals are there. Because end operation. End operation. Both should satisfy. Next one, where both initials are there, that is initial. Because of end operation, where both finals are there, that is final. Okay, that is fine. Now listen everyone. Transactions are very, very important. Not transitions. Transitions are very, very important. See this one? S13 on A. What? Which is nothing but S13 contain two states. Na? S1 also, S3 also. S1 on A check. S3 also, S3 on A also check, do union. I think S1 on A in the first machine, S2, union, right? S3 on A in the second machine, S3. So overall is going to be S2, 3. This is the way. S1, 3 on A, what? This is the final answer, S2, 3. Right? In the similar way, S13 on B, what? Check. S13 on B, what? Same story. How? S1 on B, verify. Union. S3 on B, verify. Verify first. S1 on B, what? S1. S3 on B, what? S4. Totally S14. S14. Same way, verify. S14A. Verify if you want. B here. A here. B. You may go to here. Just verify one time. Same way. A. B. I done many times. Yeah, if anyone having small doubt, I will try this also. S25 B what? Let's check. Let's check. S25 B what? Which is nothing but S2 on B union S5 on B. Right? S2 on B. Can you see the first diagram? S2 on B, S2. Union S5 on B what? S5 on B is S3. So finally S23. So on this state by giving B you will go to S23 means this. I think same. I think same. Right? So the purpose of this is called product machine. This is called as a product machine. Right? If you have individual machines, you can construct a product machine also. Why it is called product machine? First one contain 2 states, second one contain 3 states. 2 into 3, 6 states. Remember, there is no guarantee that 6 is going to be minimal DFA. DFA guarantee, minimal DFA no guarantee. But for this problem, right, it is a minimal. Sometimes it may not be. What is the reason? I will say. Some people are asking, sir, how can I conclude in the exam, sir? Very simple. Different symbol. Here, this condition on A's, this condition on B's. That means if you multiply whatever you will get, that is minimal. No doubt at all. Different symbol, please be careful. Different symbol, conditions on different symbols, then individually find out, just multiply. Right? Fine. Now same problem, that same problem I will give one more, please be careful. That's it. I think for this problem answer is going to be 6 states. For this problem answer is going to be 6 states. Right? Now see next one more problem. One more problem roughly I am giving. Can you see this one? Problem number 16 over. Let's go to problem number 17. Same construct minimal DFA for the language L is equal to. Be careful. Construct minimal DFA for the language L is equal to all strings of all strings of A's and B's. Okay, where remember everyone, each string where each string contain number of A's divisible by number of A's divisible by, be careful, number of A's divisible by 2. Right? Next one, and divisible by 2 and number of A's. Carefully here careful, number of A's divisible by 4. But if you observe clearly, all strings of A's and B's okay, but where each string contain number of A's divisible by 2, that is one condition, maybe problem P1. Next one, number of A's divisible by 4. This is the P2. Remember, same condition. See this one, same symbol. Even though B's are there, B's is not counting. Number of A's divisible by 2 is 2 states. Number of A's divisible by 4 is 4 states. That's okay. But remember, same symbol. If you don't use brain, definitely problems will come. So indirectly, directly, target is A's only. Where number of A's are divisible by 2 also and divisible by 4 also. Both should satisfy. So your condition is A's only. Your condition is A's only, not B's. So number of A's are divisible by 2 also, divisible by 4 also. I think 0 A's divisible by 2 also, 4 also. I think 2 A's if I take it divisible by 2 but not divisible by 4. If I take 4 A's, divisible by 2 also, divisible by 4 also. If I take 6, divisible by 2 satisfied but 4 not. So I think 8. Divisible by 2 also, divisible by 4 also. I think 12. Divisible by 2 also, divisible by 4 also. I think 16. I think if you observe clearly, it's almost like multiples of 4. So which is nothing but, multiples of 4. What is the meaning? S1, S2, S3, S4. See the answer? 0 satisfied, 1A no, 2A no, 2A's no, 3A's no, 4th A yes. Right, next one, 5 no, 6 no, 7 no, 8 yes. B's may come, may not come. So this is the story. This is the story. So remember, if condition is on the same symbol, you cannot multiply. If you multiply 2 into 4, 8 states will come. If you multiply, 8 states will come. If you multiply, that is also correct. But it is not a minimal DFA, simply DFA. It is a DFA. It is not minimal DFA. Right? So how to get a minimal DFA? Remember, on same symbol conditions are there. Please find out. Write like this first. Because of same symbol, na? A's only 0 A's, 4 A's, 8 A's, 12 A's, 16 A's. Right? I think if you by seeing the pattern, you can easily say. I think some people are asking, by seeing pattern, what you know, sir? Right? By seeing pattern, what I know is, see the difference. 4 minus 0, 4. 8 minus 4, 4. Right? 12 minus 8, 4. 16 minus 12, 4. I think 4, 4 gap. Means there is a loop with 4. 1, 2, 3, 4. See, that's the meaning. Common difference is 4. That is the reason. GP, it's called AP series. Between two terms, between two consecutive terms, see the difference. Between two consecutive terms, see the difference. This is called right, arithmetic progression. Right? For any series, if you can create finite automata, means AP series possible. Check if you want. For any problem, if you can create finite automata, means DFA or minimal DFA, whatever it is, N of A. For any problem, if you can create either N of A or DFA or minimal DFA, compulsory, right? In that series, AP series will come. AP series means common difference is same. Two consecutive terms you take. Common difference will be same. And how much difference is there? That kind of that length cycle will be available. Check it here. Sir, can't I multiply? Yes, you multiply. No doubt at all. You multiply 8 states. That is also correct. Product machine, you will get 8 states. That is correct. That is the DFA, minimal DFA, no guarantee. But different symbol, no, it's a guarantee. Check. If the condition is right on the different symbol, number of is divisible by 2, number of is divisible by 3. If different, you have to multiply. If same, you have to use common sense. Number of is divisible by 2 also, 4 also. I think 0. If I take 2, 2 divided by 2, but 2 is not divided by 4. Then 4. You have to use brain, means you have to first find the series. That series is AP or not, find out. In the AP, what is the common term? 4. I think there is a 4 length. There is a 4 length loop is possible. Right? This is a very, very interesting problem. Remember, same symbol, find out series. Different symbol, I think find individual, multiply. Product machine is more than enough. Right? Product machine is more than enough. More than enough, please be careful. So here final state is, see this one, because of AND operation in this problem, final state is both the finals. First diagram final is S1. Second diagram final is S3. Combinedly final is S13 because AND operation. Yes. Suppose R operation is given. Not AND operation. Suppose R operation. If R operation, first one satisfied means S1 final. Second one satisfied means S3 final. Right? R operation, because of this R operation, wherever any one is available, that is final. In the S13, at least one final there, yes. In the S14, at least one final, S1 there, S1. Next one, in the S15, at least one final, S1, yes. In the S23, at least one final, yes, 3 there. S24, I think no final. S25, no final. So R operator. Right? These 4 you have to make final. AND operation. This is only final. Same story, just because of R operator. Any one final. Any one final is there, final. AND operation. Both the final, final. So different symbols, conditions on the different, simply multiply. Is R operator, AND operator, doesn't matter. Simply multiply. If it is AND operation, common final you take. R operation, any one final is there, make it final. So for the same problem, R operator, S13 final, S14 final, S15 final, S23 final. Because at least one final required. S1 there, S1 there, S1 there, right? S3 there. So like that. R operator, this is the diagram. Same problem, R operator here. If it is AND operation, only this is final. R operation, these four are final. So I change it also. Right, like that. I think you got it. Next one, many conditions on the same symbol, you have to use brain. You have to use brain. And one more thing is, while writing the series, identify. While writing the series, please identify any loop is possible or not. Means common, right? Common term is same or not, means loop is coming. Compulsory, it is infinite language, there should be a loop. It is infinite language, number of a is divisible by 2 and the number of a is divisible by 4 also. The series whichever coming, infinite series, compulsory. So there should be a loop because finite automata contain finite states only. Finite automata contain finite states only. Finite automata contain finite states only. So try to understand. Finite automata contain only finite states. Right? With finite states, how can you satisfy infinite language? There is a loop. There is a loop. Otherwise, how it is possible? Right? I think you got it. I think you got it. So problem number 17 also we done. Be careful. If you have any small doubt also, please be careful. I will give only for namesake one small story. Only for namesake one small story. See this one P18. Construct minimal DFA for the language L is equal to, see this one, number of A's. A is divisible by, be careful, A is divisible by, A is divisible by 2, AND operation, B is divisible by, B is divisible by 3, AND operation, C is divisible by 5, right, AND operation is there. Then what is the answer is, because of condition on the different symbol, divisible by 2 states, divisible by 3 states, divisible by 5 states, 2 3 6 6 5 is 30 states. If you want, you can check. Minimal DFA contain 30 states. No need to draw also. No need to waste your time. And end operator. Suppose assume here S1 final. Suppose assume here S3 final. Suppose assume, right, here S6 final. S6 final. I think here end operation, wherever all three people are there. All three people, which is nothing but short name. S136 is the final state. Right? Common final. In the first diagram, S1 final. Second diagram, S3 final. Third diagram, S6 final. Where all final people are there, that is final because end operation. If it is R operation, any one final, that is okay. But no one will ask to draw the diagram. Everyone asks how many states are there. Everyone will ask how many states are there. I think it's okay. Let's move to next model. Be careful, everyone. Be careful, everyone. Next model. Be careful. Be careful. Everyone, be careful. Right? I think problem number 18 over. Let's go to problem number 19. Problem number 19. Some people are asking, sir, for the same, let me check one time. Construct. Only for namesake, I'm writing construct. Minimal DFA. Let me do this also. Construct minimal DFA. Right? For the language, L is equal to, be careful. A is divisible by 2. A is divisible by 2. R divisible by 3. R, be careful. Divisible by, A is divisible by 2, A is divisible by 3, right? Next one, A is divisible by 5. What is the answer? Be careful. Because of same, na, you cannot multiply blindly. You have to write the series. Let's see what will happen. Careful everyone, it's an R operator. Anyone satisfied? Okay. I think 0. 0 divisible by 2. Okay. What about 1? I think no. 1 cannot be divisible by 2 or 3 or 5. I think 2 divisible by 2. 1 satisfied? Okay. 3 divisible by 3. Okay. 4 divisible by 2. Yes. 5 divisible by 5. 6 divisible by 2 also. Right? 7. I think if you observe 7, if you observe the 7, divisible by 2 also no, 3 also no, 5 also no. No, 7 leave it. 8, I think divisible by 2 satisfied. 9 divisible by 3 satisfied. 10 divisible by 5 satisfied. 11, I think no one will satisfy. Be careful everyone. 11, no one will satisfy. 12, I think many people. 2 also, 3 also. 13, no. 14, yes. 15, yes. 16, yes. 17, no. 18, yes. 19, no. No one. Check if you want. 20, 20. Observe clearly. 20, yes. 21, 3 sevens, 21, yes. 22, yes. 23, no. 24, yes. 25, yes. 26, yes. 27, 29, 3 nines, 27, right? I think 27 also, yes. 28 also, yes. 29, I think, I don't think so. 30, yes. Are you comfortable till now? Please verify whenever number of is divisible by 2 or 3 or 5, right? Same symbol, no? Then write the series, what is happening. Right? Fine. Now, from now onwards, be careful. From now onwards, be careful. Everyone, be careful from now onwards. 30, see this one, 30, next one, 31, no, no one will satisfy. 32, yes. 33, yes. 34, yes. Next one, 34, okay. 35, yes. 36, yes. 37, no. 38, yes. 39, yes. 40, yes. So like this it is going on. So how to identify? Observe carefully. See that, can you see the difference from 30? You will get the clarity. See the difference. 2 here, 1 here, 1 here, 1 here, 1 here, 2 here, 1 here, 1 here. I think almost like this one. 2 4 ones, 2 double 1. Right? Be careful. Right? Let me do here also. 2 1 1 1 1 2 1 1 2, right? Next one, if you observe clearly, it's going to be again 2 1 1 2 2 1 1 2. I think 24 25. I think 1, next one 1 1 1 2. These two differences 2. Please check any series is repeating. I'm requesting everyone, any series repeating, please verify. Please verify any series is repeating. Anything repeating, see, there is no common difference. Common difference is not there, but at least any common series repeating. Verify. 2 4 ones 2. Sorry, 2 4 ones followed by 2 double 1 2. Check if anything common thing repeating. Now, if you see from after 40, what about 41? No, no, 41, no. 42? Yes, 42. 43, 43. After 40, 42, okay. 41, no chance, I think so. Right? 42, yes. 43, no. 44, yes. 45, yes. 46, yes. 47, 47, no. 48, yes. 49, 49, no. 50, please verify. Just R operator. Just R operator. You have to check here. No, if you see the gap, no, 2 here. Here 1 gap. Here 1 gap. Here 2 gap. Here 2 gap. Right? You verify one time. You verify one time what is repeating. So if you observe clearly, just I want to say this point, nothing there. See everyone. 2 4 ones 2, 2 4 ones followed by 2 double 1 followed by 2 2. See, nothing is repeating. Everything is keep on changing. Right? 2 first time 4 ones. 2 2 ones. Afterwards 2 2. Afterwards 2 followed by 2 double 1. 2 double 1. Again 2 2. Again 2 2 double 1. Again 2 6 1. Again 2 4 ones. Next one, right? Next one 2 2 2 4 ones. Again afterwards 2 double 2's came. Double 2's came. So what I mean to say is, can you see here? Can you see here? Afterwards, same thing repeating or not verify. So it's a 1 2 4 ones. 2 4 ones. Okay. Next one 2 double 1. See this. Afterwards, right? Afterwards, see this one. This is, I think, 2 difference. It is also 2 difference. I think 2 2. 2 2. Followed by double 1. Afterwards, again 2 2. So what I mean to say is, from here, again it is going to starting. Means after 30 states, again after 30 states, it is going back to again starting. I think this problem, if you observe this problem, right, no minimization possible, right? So I think if you multiply, divisible by 2 is 2 states, divisible by 3 is 3 states, divisible by 5 is 5 states. If you multiply 2 into 3 into 5, right, 2 into 3, 2 into 3 is 6, 6 into 5, 30 states, 30 states. Remember, 30 states is the DFA or maybe minimal DFA. DFA or maybe minimal DFA. For this problem, minimal DFA also same. Minimal DFA 30 states. We verified. Because of on the same people condition, so there may be chance of less. I verified. After 30, only same story repeating. Those people who are not getting, I want to say one thing to you. See this one. From here to here, whatever is going on, I think I have to use other color. Let me use another color. Okay, here I am using. See. From here to until 30, what is going on? Check total story. Total story until here you check. Right? From starting to until here, what series is happened. From here onwards, same story repeating again. From here onwards, same story repeating again. What does that mean? 30 states needed. Worst case 30 states. Worst case 30. I thought that there may be a chance of less because of condition on the same. Condition on the same symbol. I thought less will come. I verified. But unfortunately, nothing is repeating. But repetition is there after 30. After 30 means after 30 again you have to come back. Something like 30 states. I know very well answer will be either 30 or less. If you want, you can see the above problem. If you multiply here, divisible by 2, divisible by 3, divisible by 5. If you multiply 30, but answer if you observe, see this one. Because of it is a different symbol, directly multiplied. Because of same symbol, there may be a chance that less will come. But when I am trying, I got to know series repeating after 30. So 30 states needed. But can you go to the above problem? See. Can you go to the above problem? See this problem? I think 2 into 4, 8 states. I know very well, maximum 8. There may be a chance of less also. I verified the series. I got to know, I think 4 difference is there after every, see this one. I think 4 common difference. After every 4, you have to come back. After every 4, you have to come back. 4 states are enough. I thought similar way here, but unfortunately, there is no fixed series. But fixed series is coming after 30. So 30 states are compulsory. It's going to be very tricky question. Normally, they don't ask in the exam if anyone is not getting. Right? If you are watching this class, if you are not getting, I request you comment in the comment section. I will explain again. Right? So you can WhatsApp also. You can WhatsApp also. We are going to help you. This is a WhatsApp number. Sir, I have some doubt. You ask me, I will help. Or comment section, you can comment, I will help you. Right? That is the one model. That is a one model. Different symbols blindly multiply. Common symbol, right? One symbol only, multiple condition. Right? Then what the answer is? Upper limit is 30. Upper limit, right? On the same symbol, different conditions, na? Multiply, that is a maximum. Check any chance of minimization possible like this. If any series is repeating, then repeat. If not repeating, something like this will happen. Maximum you will go to 30 states. The minimal DFA also contains 30 states. Right? Perfect. Perfect. Now come to one more interesting story. Please listen, everyone. Please listen, everyone. Everyone listen. Everyone listen this. Careful. I'm expecting answer. Everyone have to understand. Everyone. See this. I think problem number 19 over. See the problem number 20. Observe. Problem number 20. Construct. It's an interesting problem. Construct minimal DFA for the language L is equal to. Construct minimal DFA for the language L is equal to all strings are right. Be careful. All strings are A's and B's. All strings are A's and B's where each string start and where each string start and end symbols different. This is a problem. Construct minimal DFA for the language that is equal to all strings of A's and B's where each string starting and ending symbol different. Starting ending symbol different. First understand the problem. This kind of question you can expect in the exam. Right? First understand the problem. Starting and ending symbols are different. Understand. Starting and ending symbols are different. Right? All strings are A's and B's. Starting ending should be different. I think AB. First understand by writing the language. I think BA. Starting ending should be different. Starts with A, ends with B. Starts with B, ends with A. And one more. If starts with A, ending should be B in between anything. Next one. Starts with B, ending with A in between anything. Starts with A, ends with B in between anything. Starts with B, ends with A in between anything. Yeah, it may be one length, it may be two length. Let me write now. One length, anything you take. Two length, anything you take. So you take anything, need not be one length, two length. In between, you can take anything. But remember, starting A means ending B. Starting B means ending A. Be careful. Be careful, everyone. Everyone observe. Everyone observe. Everyone observe this. See this? One state I am taken as one. I think minimal thing is 2, na? 2 plus 1, 3 states required. Minimal thing is 2, right? 3 states required. Understand everyone. Understand everyone. starts with A, it should be ends with B. Right? Final state. Next one starts with B, then ends with A. Final. Starts with A, ends with B, or starts with B, ends with A. That's perfect, everyone. Right? Now listen. Now listen. S2 means starts with A, afterwards ends with B. In between any A is no problem. Already starting A, already ending B. In between any number of A is no problem. Next one, S4 saying that starts with B, afterwards ends with A, in between any number of B is no problem because it is a DFA, already A there. So I have to write only B. So on the S1 state, A completed, B completed. On the S2 state, A completed, B completed. On the S4 state, A completed, B completed. Be careful, be careful. Remember, I want to say one important thing to all the people. Starting you cannot change. Ending only can change. Starting cannot be changed because already starting done. Now observe. Now observe here. If you are there in the S3 state means already started with A, ending with B. Already started with A, ending with B. So you are in the S3 means already started with A, ending with B. You are at S3. If at all more B is no issue. Keep sample. Suppose already started with A, many B's are coming. Stay in the S3. Suppose A comes. I think ending problem. Then wait here so that ending will come. Same way. Right? You are there in this state means BA, starting with B, ending with A. S5 means starting with B, ending with A. Ending with already A. Let's have many ways, no issue. Ending with A only. Suppose, unfortunately, you got ending is not A, B. I think wait here. That's it. It's a minimal DFA to this problem. Answer is 5 states. Please be careful. Please be careful. This is a very, very interesting problem. This problem maybe we can expect in the exam. And one more thing is, right, no dead state. No dead state. Why? Starting can be A also, B also. Both are there. Right? See, remember, if at all dead state will come because of starting condition. But starting maybe A also, maybe B also. So no issue. Remember, last symbol keep on changing. First symbol cannot change. If you go over path, starting is A only. If you go niche path, starting is B only. Right? Fine. It's a different symbol. Right? Different symbols. Starting and ending symbols are different. Starting and ending symbols are different. Right? Now listen. It is a DFA. See this one? Minimal DFA. It is a minimal DFA. Starting and ending symbols are different. Now understand. Understand. Very, very important thing is coming. Everyone understand. One interesting thing is coming. It will create a lot of trouble to all the people if you don't listen. If you don't listen, it will create a lot of trouble. This is the minimal DFA where all strings of A's and B's, where right every string starting and ending symbol different. Okay, everything fine. If we give any string where starting and ending different, it will accept. Starting with A, ending with B, above path will take care. Starting with B, ending with A, below path will take care. Right? Like that, everything is fine. Now observe. Just wait. Something nice. Yeah, fine. Now one interesting problem is coming. Please understand. Please understand. Problem number 21. Problem number 21. Problem number 21. An interesting problem is coming. One interesting problem is coming. Problem number 21. What is that one? Construct minimal DFA. Okay. Construct minimal DFA. Okay. For the language L is equal to all strings of A's and B's where each string, careful, very very interesting problem, where each string starting and ending symbol, be careful, starting and ending symbol same, where each string starting and ending symbol same. Be careful everyone, be careful. It's a very very important problem, be careful. Starting and ending symbol same, this problem should take care. Starting and ending symbol different, above problem should take care. Above problem for different, this problem for same. So let me say one interesting story. Careful, let me say one interesting story. In this language assume L1. This language assume L1. This language assume L2. Right, now see this one. In the L2, in the L1 AB there, starting ending different. In the L1 AB there, remember, in the L2 AB not there, starting ending should be same. Next one. So what is the meaning? Above one accepting means below one will reject. And one more thing, starting ending different, starting ending different, right? Starting ending different, it should reject here, it should accept here. Right, next one, please understand, starting ending same, it should reject here, it should accept here. What I mean to say is, if L1 say yes, L2 say no. If L1 say no, L1, right, L2 say yes. What I mean to say is, they both are complement to each other. That's the meaning of complementation. That is the meaning of complementation. What is the meaning of complementation? If at all you and me both are complement means, I said yes, you will say no. You said yes, I will say no. That is the meaning of complement. So starting ending different symbol. Different symbol, you will say yes, so you will say no. Right? Next one, same symbol, you will say yes, so starting ending same symbol, you will say yes, you will say no. These two are complement to each other. L1, L2 are complement to each other. Try to understand. Now, one important thing I want to say. Everyone listen. If you have a DFA for L1, if you have a DFA for L1, see this one. just wait. See this one. I have a L1 for, right? I have a DFA for L1. Very, very important one. I have a DFA for L1. Now what I will do is, L1 and L2 both are complement to each other. Na? I have a DFA for the language L1. Let me take, what is that? Let me take S1, S2. Everyone observe. S3, S4, S5. Be careful. I have a DFA for L1. Right? Whatever there, let me write all. As it is, I am writing. Nothing. I am not doing anything. As it is, I am writing. So here A, here B, here B, here A, next one, here B, here A, here A, here B, so like that. Whatever there in the above diagram, write everything same, just to do one small change. Right? Above DFA for L1, just to do one small change. What is the small change? Interchange final to non-final. In the above diagram, it is non-final, make it final. It is a non-final, make it final. It is a final, make non-final. It is a final, make non-final. It is a non-final, make final. So what I mean to say is, for the given DFA, I will take the DFA, I will change in the DFA, final to non-final, non-final to final. Then you will got L1 DFA complement you got. L1 DFA complement you got by interchanging. Right? L1 final to non-final, non-final to final. Then you will get L2 DFA. That is the meaning of they both are complement to each other. So if two languages are complement to each other, one person you construct a DFA, you no need to construct both. If you say two languages are complement to each other, then what you do is for one language construct DFA. In that DFA, final to non-final, non-final to final, you change. Then you will get the L2 DFA. This is L2. This is L2. Understand? This is L2. Which is complement of L1 DFA. Remember, complementation possible only for DFAs or minimal DFA. DFA only you can do complementation. NFA means non-deterministic, no guarantee. DFA surely will give complementation. I have a DFA for L1, do complementation, you will get L2. I have a DFA for L2, do complementation, you will get L1. Remember complementation possible only for DFAs. So I am writing note, complementation possible only for DFAs, NFA to NFA complementation, no guarantee. See, two people, I cannot say guarantee complementation. What is the meaning? I will say yes. Me and my bhaiya, I cannot say complementation. Me and my bhaiya, I cannot say sometimes I like, my bhaiya also like. Right? Sometimes I know, I like, you don't like. Sometimes, right? Because two people need not be same, right? Two people need not be same. Sometimes I will say yes, he will say no. Sometimes I will say no, he will say yes. Sometimes I will say yes, he also say yes. That's the meaning of complementation, NFA, no guarantee. After complementation also, before complementation he is saying no. After complementation also, he may say no. NFA, no guarantee. But complementation possible only for DFAs. When you say DFA, minimal DFA also DFA, right? It's one kind of DFA. Complementation possible only for DFAs. If you want, you can write minimal DFA also. Okay, minimal DFA also DFA, that's the reason. But NFA complement, no guarantee. No guarantee. Me and my madam both are complement. I say yes means she will say no. She said yes means I will say no. We both are complement. But me and my bhaiya, no guarantee. I may say yes, sometimes he also say yes. But you never find out. I said yes, my madam also said yes. I said no, my madam also said no. It is not like that. Right? Me and my madam is pakka complementation. Me and my bhaiya need not be complementation. Right? Some people are asking, sir, I have a DFA for a particular problem. Right? Can I do complementation? Exactly, you can do it. If for every DFA or a minimal DFA, you can do complementation. What is complementation? Exchanging final to non-final, non-final to final, remaining all same. Exchanging final to non-final, non-final to final, remaining all same. Sir, some people are asking, what do you get by doing complementation? Suppose before complementation something yes, after complementation it should be no. Before complementation something no, after complementation it should be yes. If you want, you can verify here. Before complementation, see this, before complementation here in the first diagram, epsilon is not accepted because starting state, final state both are not same. Epsilon not accepted, but here epsilon accepted. See, starting state, final state same, epsilon accepted. Before complementation, right, A is not accepted because A starting symbol also A, ending also A not accepted, but here A accepted, check. Before complementation, B not accepted, here B accepted. Before complementation, A 4 B's, accepted. But here A 4B is not accepted. Check. A 4B is not accepted. We are in the S3 only. And one more. What is the meaning of complementation possible? What is the meaning? Suppose if L1 and L2 are complement to each other, that means L1 intersection L2, nothing common. L1 union L2. Whatever L1 is not covering, L2 will cover. Whatever L2 is not covering, L1 cover. If you do union, everything will cover. To complement people, if you do union, everything will come. Right? To complement people, if you do intersection, nothing will come because nothing is common. Then I can say those two are complement to each other. Then I can comment L1 complement is L2. I can comment R. Then I can comment L2 complement is L. That is the meaning of complementation. Complement, two people are complement to each other means intersection is pi, union is everything. N of A, no guarantee. Suppose assume L1 is N of A. Suppose assume L1 is N of A. You done the complementation, you got L2. I cannot say intersection is pi because, right, N of A complementation, no guarantee. After doing intersection, you may not get pi. After doing union, you may not get sigma star. No guarantee. N of A means non-deterministic behavior. No guarantee. Right? No guarantee. I think people got it. Let's go to next. I think everything is fine. Let's go to next. Let me save first. Classes, TOC, crash course. Yes, I'm saving. Yeah, saved it. Let's go to C3. Be careful, everyone. So I think previous one. What is the last problem number? Problem number 21. Problem number 21. Let's go to problem number 21, 22. Be careful, everyone. Problem number 22. Problem number 22. Construct minimal DFA. Everyone observe. Construct minimal DFA for the language L is equal to. Everyone understand? Construct minimal DFA for the language L is equal to. Right? For the language L is equal to. Just I have to find out different model, so I'm trying this. Just understand. Construct minimal DFA for the language L is equal to A power, right? One important thing I want to say to you, everyone listen. A power M, B power N, where M comma N greater than or equal to 0. This is a problem. Assume that. This is a problem. Construct minimal DFA for the language L is equal to A power N, B power N, where M comma N greater than or equal to 0. This is a problem. First, what you do is write the language first. I think 0 also possible, epsilon. I want to say in this problem something, right? First learn it. First, what is the purpose of this problem? I will explain. Right? First epsilon. Okay, that is fine. Next one. Only A is possible? Yes. Only A is possible. Only B is also possible. A is followed by B is also possible. Right? But remember, B is followed by A is not possible. Next one. So many A's followed by so many B's. Right? This is the language. I think you are fine with the problem. Construct minimal DFA for the language L is equal to A power n, B power n, where M comma n greater than or equal to 0. So like this. So I think everything is fine. Now understand. understand one important thing. Be careful, understand one important thing. So for this one, you have to construct a minimal DFA, right? But here, if you observe clearly, only A is okay, only B is okay, A is followed by B is also okay. A is followed by B is also okay, right? Now see what happened. So minimal string is epsilon, zero length. It is a zero length, 0 plus 1. With one state start automata. Okay, I started. Epsilon is already accepted. Right? Epsilon is already accepted. Be careful. Epsilon is already accepted. And next one, right? Understand. Next one, only is. That is also okay. Only A is also okay. Epsilon accepted, only A is also okay. Now see this one. Suppose if I keep B also, right? B is also coming, A is also coming, fine. But A is followed by B is also there. B is followed by A is also problem coming. Order problem. B is followed by A is also coming. Then what happened? If B comes, then go out. If B comes, then go out. Then go to S2 state, single B also accepted, followed by any number of B's. Now, if you observe clearly in this diagram, right, epsilon possible, only A is possible, A is followed by, sorry, only B is also possible, A is followed by B is also possible. I think fine, that is perfect. But remember, it is N of A. Remember, it is N of A. Suppose if you want to make a DFA, I think some dead state also required. How? After, right, S2 means already I see in B's. After B's, A is not allowed. Dead state will go itself. So on every state, A, B covered. So it is a DFA. It is a DFA. And one more, it is a minimal DFA. It's a minimal DFA. If you want, you can check. One state also you cannot eliminate. Here one state also you cannot eliminate. It is a minimal DFA. Only A's, only B's, A's followed by B's. After B's, you never see A. Right? Minimal DFA this. Right? Now listen. One interesting story. Everyone listen. Right? So, see this. It's a minimal DFA. Careful ones. So, minimal DFA creation, everyone knows some difficulty there, right? Because of I done many times, I got clarity, I done. Some people, they have some doubt how to construct a minimal DFA. But some people, what they will do is, minimal DFA creation is a little difficult. What some people will do is, right? They will do like this one. I think only A is okay, only B is okay, right? A is followed by B's. B is followed by S cannot be. A is followed by B's. So there is a one more simple method. Can you see this one? S1. Everyone observe. S1. Only A is okay. Epsilon okay, fine. Only A is okay. Right? Only B is also okay. Observe here. Only A is okay. Only B is okay. That is also fine. Right? So remember, if at all both will happen after A's only B's, so you can keep epsilon in between. Only A's, fine. Directly B's, yes. Epsilon dot B means B. So only B's, you can go here. Followed by any number of B's, then B's only. 4 B's. Next one. A's followed by B's. Yes, that is also okay. So what I mean to say is, whenever order is important, if you think that DFA construction become difficult to you, you can keep on the transition line epsilon symbol. This is called epsilon N of A. On the transition line, you can keep epsilon. That is called epsilon N of A. For comfortability, this is very difficult. This is very difficult to construct, but this is easy. This is very easy, right? Null transition purpose is it will give the flexibility to you. So you want to do only A's, do only B's, do sometimes A's followed by B's also. Oh, order is important. In between keep null transition. It will make your life easy. It will make your life easy. I think everyone got it. I think everyone got it. Now see one more interesting story. Just see one more interesting story. S1, okay. S2, that is also okay. Everyone observe. Only A is okay. Be careful. Only A is okay. Only B is okay. Fine. After all A's are over, you may go here, A or B. A also go to here, B also go to here. A also go here, B also go here. After coming here, only B is allowed. If you want only A's, stay here. If you want B's also, yes, right? If you want only B's, you can go like this. Right? Only B's, you can go like this. A's followed by B's, A's followed by B's also okay. Some people are asking, already A there, why you written A? If you write like this, you may not face any problem, but it is N of A. Okay. Some people are asking, sir, don't write this unnecessary. That is perfect. Now some people are asking, sir, if I go to S2, sir, if I go to S2, already B's came. After B's, A is allowed or not? Not allowed. So should I write trap state? You no need to write. If it's N of A, no need to take trouble. N of A, no need to take trouble. In N of A, unnecessary things you no need to concentrate. In N of A, you no need to concentrate unnecessary things. Right? Fine. It's N of A. So remember, easy construction is easy construction. Epsilon N of A. Next, little more easy, this. Very difficult, this. So this is right. Let me say once. It is very easy. I am using the different colors. It is easy. It is medium construction. It is difficult. So if your goal is constructing DFA, try if possible like this. If possible, try like this. If not possible, you try like this also. And one more thing, remember, epsilon N of A possible means N of A also possible. N of A possible means epsilon N of A also possible. All three having same power. Different ways of representation. In Hindi language, something possible means English also possible. In the English language, something possible means Tamil language also possible. Bengali language also possible. Different ways of saying. So all three having same power. Let me read now. Expressive power of DFA. This statement is very, very important. Expressive power of DFA. Expressive power of minimal DFA. Expressive power of N of A. Expressive power of epsilon N of A. Next one, expressive power of regular expression. All same, all having same power. Different way of representation. Please be careful. All are having same power. Sir, DFA there, N of A not there? No, both are there. Sir, N of A there, epsilon N of A not there? Both are there. Whichever is easy to you, do that. Normally easy is epsilon N of A. Why? Oh, first A's, then B's. A's may come, may not come. B's may come, may not come. So A's in the S1 state, B's in the S2, in between. Epsilon you write. Epsilon will separate them. If you think that without epsilon I can do some, Maybe you can do this. Right? But here unnecessary stuff I don't cover. If you cover unnecessary thing also, DFA will come. Unnecessary thing also, if you cover, DFA will come. Now I will just do one small story. Everyone listen. I will just say one small story. One small story I will say. Just listen. One small problem I will do. With that, this one note I want to say. Other than this, nothing there. One note. Remember, for NFA, DFA there. Right? NFA there means DFA there. DFA there means minimal DFA there. Right? All are there. All these five, whatever I written, five maybe I written, all are available. One available, all available. One available, all available. Right? Now I will do one problem which is required to say that note. P23. Problem number 23. 23 or 24? Problem number 22 or 23. Can you see problem number 23? See correctly. S1, S2. Understand? S1, S2. A, B. S2 may be final, S1 may be initial. I am giving transition table. Here, S1. Here, S2. Here, nothing. Here, S1, S2. Be careful. So, by seeing this table, you got to know it is NFA. Right? Everywhere 1 is there, that is a DFA. Everywhere 1 that is a DFA. But here combinations are there. See this. Here 2 there, here nothing there. So here no problem. Here see more there, here nothing there. So it's NFA. Remember, it is NFA. It is NFA. Some people are asking, sir, how to construct equivalent DFA? Because for every NFA, DFA there. For every NFA, DFA available. How to construct? Very simple. Can you see this? Careful everyone. I am constructing DFA. Very simple. Because for every NFA, DFA there. For every DFA also NFA there. Both are having same power. The only thing is one is easy, one is difficult. NFA easy. So construct NFA, do conversion DFA. Some people are asking, sir, what you are going to do now? I am doing conversion. How, sir? Right? Very simple. In the NFA, whichever is starting state, you also take. In the NFA, whichever is starting state, you also take same. Right? Now, every time you have to see NFA. Only take starting state. Don't take remaining. Only take starting state. Other states don't take. Only take starting state. Right? Every time see the right NFA. In the NFA, S1 on A, where are you going? S1, no issue. If one person coming, no issue. DFA saying, I also don't have any issue. Next one, S1 on B, where are you going? Every time you have to see NFA. Every time, because you are doing NFA to DFA. So DFA will get the information from NFA. See that. S1 on B, where are you going? S2, no issue. So till now, no problem. So you started from S1, right? In the NFA, whichever is initial state, take the same person. Apply inputs. S1 on A, S1. S1 on B, S2. Now what you do is, see this one. To this line left hand side. S1. Now the states whichever came till now, is there any new came comparing this person? Because left hand side only this person you were taken. After applying, please check. Except S1, anything new? Yes, this. New person only take. A new person apply again same story. See the NFA. In the NFA, what is S2 on A? On NFA, some people are asking, sir, why you taking S2? Whichever is the new person. Comparing this S1, after one round is over on the S1, take initial, do one round. Whichever is the new person, that new person take. Do again same story on the NFA. Please check. S2 on A. In the NFA, where are you going? You are not going anyway, but in the DFA you have to go somewhere, right? It is not going, but you have to go. That is called dead state. Go dead state. Next one, S2 on B, where are you going? Just give 1 minute. Just give 1 minute. 1 minute. Right. So S2 on A, in the N of A, no one going. So DFA you have to go. So dead state. S2 on B, if you see the N of A, S1, S2. But in the case of DFA, you have to go to one only. You have to go to one only. Remember everyone. Remember everyone. Right? That state name is S1 also, S3 also, S1 also, S2 also. This is, remember, S1, S2. It is one state now. This is one state now. The state name is S1, S2. Previously they are two. But in the case of NFA, DFA, multiple states not allowed. But you are going multiple, so make it as, right, one state name. So this may be Ravi, this may be Kishore. Right now one more person name is there, Ravi Kishore. Right, now see the answer. So on the left hand side of this line, if you see two states are there, comparing these two people, who are the new people here? I think this is new, this is also new. So take one of the new person, dead state. Dead state will go itself. Dead state will go itself. Now comparing these three people, anything new? I think this is right. Now let me take S1, S2. Right? It is a one state name. Now see S1, S2 on A. S1, S2 on A. What is the answer? S1. Next one. S1, S2 on B. What is the answer? C on. S2, S2, S1. I think S2 two times, keep one time only. So S1, S2. I think comparing these four people, anything new? Comparing these four people, anything new? Comparing these four people, anything new? Comparing these four people, anything no new. So means N of A to DFA construction completed. Nothing new. So N of A to DFA construction is completed. Now you may say that sir, which are final? Whichever is final here, I think is final. So wherever you see that person, that will be the final. So I think S2 is final here. So wherever S2, see there, here, here. So that is final. So the final for this N of A equivalent D of A contain S1, S2, next one is S1, S2 dead state. Right now see, starting state is starting, so final, wherever S2 that is final. Wherever S2 that is final. Right, next one. S1 on A, S1. Next one, S1 on B, S2. Go to the S2. S2 on A, dead state. Right? S2 on B, S1, S2. Next one, S1, S2, S1, S2 on A, S1. S1, S2 on B itself. Dead state itself. If you want, you can verify. I done the N of A to DFA conversion, so please check. Please check, already you may be having, right? So for this N of A, if you want, you can do the equivalent DFA, same diagram you will write. This is the conversion. This is the conversion, right? Thank you so much, right? We'll see in the right next class, right? Further story, right? Thank you so much. Thank you. See you in the next class.